Alright, so in the last episode, we initialized our display buffer and wrote an E to the screen. I've taken the liberty to make our, make our previously, hang on, let me step through that. Our previously, I think, green or yellow E, grayish, because I think that suits us better as a background color. And I will, for now, just define that as our default text color will be this. We will just OR that with the character we want to print. And in this episode, we will get a print function to draw things to the screen. So what we will need is, obviously, we will need some test text. And this allows, or the compiler allows us to use string literals, but we need to have some sort of termination character, which will be 0. So we use C-style strings. So we need to append a 0 byte to know, or a 0 word, to know that it ended there. Okay, so we have our test text, we have our default text color, but what we also need is a cursor position for a buffer. And I will initialize that to the same position as our display buffer to make sure that it's where we expect it to be. And now we will write another subroutine and take this one out for now, because we don't want to print our E now that we get a proper print routine. So we need to have some sort of convention for how the print routine works. And for now, I will use a pretty junky one, namely no function guarantees anything. So if you want to keep a value after using a function, you need to push it to the stack and then pop it back from the stack. There are more efficient ways. If you guarantee certain registers stay the same, you don't need to push and pop stuff, but it has to be across the board in every routine. And I will do this later when I clean up some code. So we will start with the print routine now. And I will say that the print routine needs to get the A register set to the address of what has to be printed. So what I will do is I will set, first of all, I'm a bit confused right now, I don't know why. So first of all, new subroutine, put this at the end to make sure we always get back to where we came from. And now what I want to do is I will set, I will set I to the value at cursor position, so we can count up from there. And then I will start running a loop. And that loop will terminate. Hang on. First of all, we need our loops label. And here we will add 1 to A. And we will add 1 to I, because we want to count up our loop. And then what we want is, if A is not 0, then we go back to our loop. Alright, but I don't want A, but I want the value at A, because A points to the string I want to print to a screen. So the last thing I need to do really is I will set I, or the value at the position of I, to the value at the position of A. And now we will write to that memory location, but we won't see anything because it's black. So we resort back to our default text color. I think I'll make that a small c. Our default text color. And what I want to do now is I will set the B register to what's at A, and then let me look up the specs. There has to be an exclusive OR or just an OR. I guess I want an OR. Bitwise OR. Alright. So B contains the value at A. And now we will bitwise OR the value of B with the value at default text color. It would be faster to store this in some routine previously, or in some register rather, because now we need to read every time. But it's clearer this way. Later in the series I will make a lot of stuff more efficient, but for now I will leave it like this because it's more readable in my opinion. So B contains the value of the character at A and is ORed with the bitwise ORed, obviously, with the default text color. So it should start with 70 and then contain the ASCII value for the character. And then we set I to B, and this should run through nicely, and in the end we've printed stuff to the screen. And on top of that, I think I should add a space at the end of this, because we never set our cursor position back. So it should kind of print the whole screen full of this. But of course we don't print anything yet. So the last thing we need to do is set A to test text, I think is what I called it. Hang on. Yep. But no brackets here because we actually want the address. And then we JSR print. And I really hope that this works. And I will remove these. And let's see. Hang on. Recompile and start. Okay, so we ran here. The display has been set up, so now the screen is black, and now we call the print routine. And we get this as a string. And it terminated, we are back here. So let's run this again, and again, and again, and again. And it's just fine. It works out really well every time. Oh, okay, I made a mistake, which makes it seem like this works way better than it does. Well, not way better, but I actually forgot that at the end of this, obviously I want to store the new cursor position at the end. So what I need to do is, at the end of this, set cursor position to I, because we've already written to all of that. So let's do this again. This is a string, another string, more strings. So now we print our screen and we print at the correct offset. And this is obviously really useful if you want to write an OS. But now you can see we actually write to more memory than we need. Our screen's already full, so the more I run this, the further down do we fill up our memory, which is a bit but on the other hand, it's sort of right, I guess. And potentially, if we do this too often, we will override our own program. And you can see here, we've stored this is a string as a literal value here, but we've written to the memory at the other address much more. So now we can print stuff to screen. And in the next episode, I think I will start with keyboard input, and then we will start getting to work on making an actual OS and not just like a toy for writing to the screen and reading keys from a keyboard. But this is a good start, I think, and I'll just say see you.